We tend to look at the ground beneath our feet as the definition of stability. In our short human lives, the continents seem like permanent fixtures, massive, immovable rafts of rock that have settled into their final positions. We look at a map of Africa and we see a single, solid landmass that has stood the test of time. But that map is a lie. The reality is that the Earth is not finished. It is still under construction, and right now, beneath the cradle of humanity, a colossal war is being waged. It is a geological violence that is mostly invisible to the naked eye, but its scars are already etched across the landscape in a 6,000-kilometer wound visible from space. We call it the Great Rift Valley. For decades, the scientific consensus was optimistic. We believed we were witnessing the birth of a new ocean, a slow, majestic separation of land that would eventually reshape the globe. But recent evidence suggests something far more volatile might be happening deep in the subterranean dark. We are looking at one of two futures for the African continent. Either the map of the world is rewritten by the cooling waters of a new sea, or Africa suffers a catastrophic geological stall that could unleash forces we haven't seen in millions of years. Before we crack open the Earth's crust, look down. If that subscribe button is still red, click it right now. We explore the planet's deepest secrets every day, and you don't want the algorithm to bury the next discovery from you. To understand the scale of this threat, we have to look at the engine driving it. The stability of the African continent is an illusion. Africa is not sitting on a single tectonic plate. It is actually being torn between two. To the west lies the massive Nubian plate, which carries the bulk of the continent. To the east lies the Somali plate, encompassing the Horn of Africa, Kenya, and Tanzania. For roughly 25 million years, these two giant rafts of rock have been drifting away from each other. It is a tug of war on a continental scale, but the situation is even more complex than a simple split. To the north, the Arabian plate is also pulling away, dragging the crust toward Eurasia. This creates a geological triple junction in the Afar region of Ethiopia, a point where three tectonic plates meet and pull in three different directions simultaneously. It is the exact point where the Earth's crust is being stretched so thin that the mantle is practically knocking at the door. This isn't happening by magic. It is driven by the heat engine of our planet. Deep within the Earth's mantle, thousands of kilometers down, there is a structure known as the African Superplume. It is a massive upwelling of superheated rock rising like a mushroom cloud in slow motion. Think of it like a pot of thick soup boiling on a stove. The hot material rises, hits the solid crust from below, and spreads out. As it drags along the bottom of the lithosphere, it acts like a conveyor belt, pulling the continent apart centimeter by agonizing centimeter. This is the exact same process that ripped the supercontinent Pangaea apart nearly 200 million years ago, creating the Atlantic Ocean. And for years, this was the accepted timeline for Africa. The theory is elegant. As the Nubian and Somali plates continue to separate, the land between them will sink. The valley floor is already dropping. Eventually, the floor of the Rift Valley will drop below sea level. When that happens, the barrier holding back the Indian Ocean will breach. The waters will rush in, flooding the deserts and valleys of Ethiopia, Kenya, and Tanzania. The Horn of Africa will become a massive island, a new mini-continent sailing off into the Indian Ocean, leaving the rest of Africa with a brand new coastline. In this scenario, the violence is creative. It builds new trade routes, new climates, and new ecosystems. In fact, we can already see the benefits of this thinning crust today. Because the heat is rising so close to the surface, East Africa has become a geothermal powerhouse. Countries like Kenya and Ethiopia are tapping into this, turning the very forces that are ripping them apart into clean, renewable energy. It paints a picture of a slow, manageable transition into a new geological era. But there is a darker alternative, a possibility that turns this creative engine into a mechanism for destruction. What happens if the rift fails? It sounds counterintuitive. Surely, a failed rift means nothing happens and everything stays the same. Unfortunately, in geology, a failed rift is often more dangerous than a successful one. We have seen this happen before. Over 1 billion years ago, right in the heart of North America, the continent began to split apart. This was known as the Mid-Continent Rift. It stretched from what is now Lake Superior all the way down to Kansas. The continent was ready to break, but then the process stalled. The plates stopped moving apart, but the pressure from below didn't stop. The mantle plume kept pushing up. Heat kept building, and the magma had nowhere to go. Because the Earth didn't crack open to release the pressure sideways, the magma burst upwards. The result was a catastrophic outpouring of lava known to geologists as a large igneous province. We aren't talking about a single volcano erupting like Mount St. Helens. We are talking about flood basalts, walls of lava erupting from massive fissures in the ground, flowing for hundreds of kilometers, burying the landscape under layers of rock so thick they remain there a billion years later. The heavy mineral deposits around Lake Superior today are the scars of that ancient failure. This is the danger facing Africa today. If the tectonic forces aren't strong enough to fully snap the plates apart and create an ocean, the East African rift could become a failed rift. The magma accumulating beneath Kenya and Ethiopia would eventually breach the surface, not as a new ocean floor, but as a continental flood. In Earth's history, events like these are often linked to mass extinctions. The Permian-Triassic extinction event, also known as the Great Dying, was likely driven by a similar event in Siberia. The sheer volume of sulfur and carbon dioxide released by such massive lava flows can alter the global climate, plunging the planet into volcanic winters or super greenhouse events that last for millennia. So, which future are we looking at? The evidence is conflicting, and that is what makes this region so fascinating and terrifying to geologists. On one hand, we see the classic signs of separation. In 2005, the Dabahu fissure in Ethiopia ripped open. In a matter of days, a crack 60 kilometers long and 8 meters wide unzipped the desert floor. It wasn't erosion, it was magma injecting itself into the crust, pushing the land apart with the force of a hydraulic press. This suggests ocean formation model is still in play and the zipper is opening. On the other hand, we see strange volcanic behavior that hints at the failed rift scenario. We look at the volcanoes in the region, specifically Mount Nyiragongo in the Congo and Old Doinyo Lengai in Tanzania. They are behaving in ways that defy standard volcanology. Nyiragongo possesses some of the fastest flowing lava in the world. In most places, you can outrun a lava flow. In Nyiragongo, the lava flows like water, reaching speeds of up to 60 kilometers per hour. This is due to its extremely low silica content. High silica lava is thick and sticky. Low silica lava is runny. This suggests the magma is coming from very deep within the mantle and it is ready to move fast. If the crust fails to split and instead ruptures, this is the type of lava that would flood the continent, fast, unstoppable, and devastating. Meanwhile, Old Doinyo Lengai erupts carbonatite lava, a bizarre, cool lava that is black like motor oil and turns white when it dries. It erupts at temperatures barely hot enough to burn wood, yet it is highly fluid. It's unique in the world, another signal that the plumbing system beneath East Africa is unlike anywhere else on the planet. We are seeing increased seismic activity. We are seeing the crust thin. We are seeing the ground literally groan under the strain of the mantle plume beneath it. The Earth is trying to make a decision, split or burst. However, before you start worrying about a global volcanic winter happening tomorrow, we need to talk about the concept of time. Human history is a blink of an eye compared to geological history. These processes move at speeds we can barely comprehend, not because they are fast, but because they are agonizingly slow. The plates are moving apart at roughly the rate your fingernails grow, a few millimeters a year. To the Earth, a million years is a minute. Whether Africa splits into two distinct continents or suffers a massive volcanic stall, the climax of this movie is millions of years away. We are just the spectators in the opening scene. We will not be here to see the new ocean coastline of Ethiopia, nor will we be here to see the flood basalts cover the Serengeti. But that doesn't make it any less significant. The East African Rift is a reminder that we are living on a dynamic, restless planet. The ground beneath us is not a finished product, it is a work in progress. The Great Rift Valley is a reminder that the Earth is alive, driven by fires that have burned since the formation of the solar system. Africa is changing. The map you see today is just a snapshot in time, a single frame in a movie that has been running for 4 billion years. Whether it ends in the birth of a new ocean or a flood of fire, one thing is certain. The world of the future will look very different from the one we know today. Geology teaches us patience, but it also teaches us that nothing is permanent. Not the mountains, not the oceans, and certainly not the continents we call home. If you want to keep exploring the incredible forces that shape our universe and our history, and if you want to understand the ground beneath your feet a little better, make sure to hit that subscribe button and turn on notifications. There is a lot more to discover.